Hi viewers, welcome to Learning Electrical Engineering channel. In this video, we will see how to solve the problem using Thevenin's theorem, which is having the dependent source as well as independent sources. So the given problem is find the Thevenin equivalence of the circuit in the below figure. This is the figure. In this one independent source of current sources, independent source of current source 5 amps is available. Here one dependent source, the value of dependent source is 2vx, and vx is the voltage drop across the 4 ohm resistor. As we know that to draw the Thevenin's equivalent circuit, we must know the two parameters, that is vth and rth. Vth is the Thevenin's voltage and rth is the Thevenin's resistance. The Thevenin's voltage is the voltage across A and B terminals. RTH is the, we need to turn off the independent sources, then we need to find out the resistance while looking from the A and B terminals. Now we will start to find out the open circuit voltage or the VTH across the terminals A and B. Let us start. This is the circuit. Now we need to find out the voltage across the terminal A and B. This is VTH. The VTH is equal to the voltage drop across this 6 ohm resistor. The whatever the voltage drop available across this 6 ohm resistor, that will be present across the terminals A and B, which is equal to Thevenin's voltage. To find out the current voltage drop across this 6 ohm resistor, we will use the mesh analysis. For mesh analysis, we will mark the loop currents. Let us say this is loop 1, this is loop 2, and this is loop 3. For the loop 1, the current in loop 1 will be I1, and the direction of current is as marked in the diagram, and the loop current for the second loop is I2 and direction is marked here, and for loop 3 the loop current is I3 and direction is shown in the figure. Now as per this loop currents, the voltage drop across the 6 ohm resistor will be 6 into I2, because the amount of current flowing through the 6 ohm resistor will be I2. So we need to find out the value of current I2, then we can find out the VTH. To find out the I2, let us start to apply the KVL in the first loop. So when we applying the KVL in the first loop, we can write 4 into the current through the 4 ohm resistor is involving both currents, that is I1 and I2. So I1 is flowing from top to bottom and I2 is flowing from bottom to top. So both are in opposite in direction. So we can write 4 into I1 minus I2, which is equal to here what that is Vx. Now in this loop current, we also notice that the value of current I1 is equal to 5 amps. The equation 4 into I1 minus I2 is equal to Vx, let us say this is equation number 1. Now we will write the we will apply the KVL to the second loop and we will write the equation. When we applying the KVL to the second loop, the current flowing through the 2 ohm resistor is involving I2 and I3, but both are in opposite in direction. So we can write 2 into I2 minus I3, and the current flowing through the 6 ohm resistor is I2. So we can write 6 into I2, and the current flowing through the 4 ohm resistor is involving currents I1 and I2, and both are in opposite in direction. So we can write 4 into I2 minus I1, which is equal to 0. As we know that I1 is equal to 5 amps, we will apply it here. So in this when we simplifying this equation, so the I2 terms are 2I2, 6I2 will be 8I2 plus 4I2 will be 12I2, and I3 term will be only one term is available, so negative 2I3, and I1 term is minus 4I1. So we can write I1, we know that there is I1 is equal to 5 amps, so 4 into 5 will be 20, so negative 20 is equal to 0. On further simplifying, we can write 12i2 minus 2i3 is equal to 20. Let us say this is equation number 2. Now we will apply the KVL in loop 3. So when we applying the KVL in loop 3, the current flowing through the 2 ohm resistor is involving I2 and I3, but both are in opposite in direction. So we can write 2 into I3 minus I2, and the loop current I3 initially meets the negative terminal of the dependent source. So we can write negative 2Vx is equal to 0. On simplification of this equation, we can write Vx is equal to I3 minus I2. So let us say this is equation number 3. Now I want to find out the value of current I2. To find out the value of current I2, we need to find out the value of I3 in terms of I2. For that, we can equate 1 is equal to 3. So the equation 1 is 4 into I1 minus I2. So I can write 4I1 minus 4I2 is equal to I3 minus I2. We know that I1 is equal to 5 amps. So we can directly write 20, and the value of negative 4i2 when we transferring to the right hand side of this equation, so it will become positive 4i2 minus I2 will be positive 3i2 plus I3. So when we rearranging this equation, we can write 3i2 plus I3 is equal to 20. Let us say this is equation number 4. Now we will find out the value of current I2 by solving the equation number 2 and 4. So for solving this, I want to cancel out the term I3. So we can multiply the equation number 4 by 2. So the equation will become 6i2 plus 2i3 is equal to 40, and the equation 2 we can directly write as it is. So the value will be 12i2 minus 2i3 is equal to 20. When we solving this, the negative 2i3 and positive 2i3 will be get cancelled out. The remaining will be 18i2 is equal to 60. Now on simplification, the value of I2 will be 60 divided by 18, so which is equal to 10 by 3 amps. Now which is when I2 is equal to 10 by 3 amps, and the voltage drop across the 6 ohm resistor will be, that is VTH is equal to I into R. I will be 10 by 3 into the value of resistance is 6 ohm. The value of VTH is equal to 20 volt. Fine. So VTH is equal to 20 volt. Now we need to find out the value of RTH. For that, in this step we need to find out the value of RTH, that is Thevenin's resistance, when we looking from the terminals A and B. So to turn off the current source, that is independent source, we need to do the open circuit. Here we did the open circuit. Now we need to look from the terminals, open circuit terminals, that is A and B, and we need to find out the value of current resistance of this circuit. Now the problem involving in this kind of circuit is the availability of dependent source. In this case, we need to inject the voltage between terminals A and B, then we can find out the value of current delivered by this voltage source, then we can find out the value of resistance by applying the Ohm's law, that is R equal to V by I. If I am injecting the voltage, I will find out the value of current I, then we will find out the value of RTH. In case if I am injecting the value of current I, then I need to find out the voltage across the terminal A and B, then we will apply the value V here, then we know the value of current, injecting value of current I here. From this we can find out the value of resistance R. Now in this circuit we will apply the known value of voltage source, that is 1 volt plus minus, that is 1 volt, which is equal to V0. Now we need to find out the value of current I0. To find out the value of current I0, we will apply the mesh analysis again here to find out the value of current I0. To apply the mesh analysis, we will mark the loop currents. Let us say this is the first loop and the loop current is I1 and the direction is shown in figure, and this is loop 2, the loop current is I2, direction is shown in figure, and this is loop current I3 and direction is shown in figure. Now we will apply the KVL to the number 1, number 2 and number 3 loops to find out the value of current I0. As we know that the value of loop current I1 is equal to I0. So to find out the value of loop current, we will start to apply the KVL to the loop 1. When we are applying the KVL to the loop 1, 2 into I1, and the current flowing through the 6 ohm is involving the two currents I1 and I2, and both are in opposite in direction, so we can write plus 6 into I1 minus I2, and the loop current I1 initially meets the negative terminal of the voltage V0, that is 1 volt, so I can write negative 1 is equal to 0. So on simplifying this, we can write 8I1 8I1 minus 6I2 is equal to 1. So let us say this is equation number 1. Next we will apply the KVL to the second loop. When we applying the KVL to the second loop, the current flowing through the 2 ohm will be involving the current I2 and I3, and both are in same direction, so we can write 2 into I2 plus I3, and the current flowing through the 4 ohm resistor will be I2 4I2, and the current flowing through the 6 ohm resistor will be 6 into I1 and I2 currents are involved and both are in opposite direction, so we can write 6 into I2 minus I1, which is equal to 0. Here one more thing we need to note is Vx is equal to, here Vx, this Vx is equal to 4 into I2. This must be understood from the diagram. Now when we simplifying this equation, the I2 terms will be 2 into I2, 2I2 plus 4I2 will be 6I2 plus 6I2 will be 12I2. So we can write 12I2, and I3 term is only one term is available, so that is 2 into I3, and I1 term is only one term is available, so that is negative I6I1 is equal to 0. Now let us say this is equation number, let us say this is equation number 2 and this is equation number 3. Now we will write the equation, we will apply the KVL to the loop 3 and we will write the equation. So when we applying the KVL to the loop 3, we can write 2 into the currents involving in the current flowing through the 2 ohm resistor involves I2 and I3 and both are in same direction, so we can write I3, 2 into I3 plus I2, and the loop current I3 initially meets the negative terminal of the 2Vx, so we can write 2 negative 2Vx is equal to 0, and simplification we can write Vx is equal to I3 plus I2. Let us say this is equation number 4. Now we know the equation number 3 is equal to equation number 4, So from this we can write 4i2 is equal to i3 plus i2, and 3i2 is equal to i3. So let us say this is equation number 5. Now when we applying the equation number 5 to the equation number 2, apply equation 5 in equation 2. So the equation will become 12i2 plus 2 into 3i2, because i3 is equal to 3i2, we will apply the value of i3 here. So 2 into i3 is equal to 3i2 minus 6i1 is equal to 0. So the equation will become 12i2 plus 3 into 2 into 3i2 will be 6i2, 6i2 plus 12i2 will be 18i2, 18i2 minus 6i1 is equal to 0. Now let us say this is equation number 6. When we see the equation 1 and equation 6, I am interested in finding out the value of current I1, so I will cancel out the value of I2. So to cancel out the value of I2, I can multiply the equation 1 with the value of 3, will become 24I1 minus 18I2 is equal to 3, and the equation 6 we can write as it is. So negative 6i1 plus 18i2 is equal to 0. So the equation will when we solving this, the equation will become 18i1 is equal to 3 and I1 is equal to 1 by 6 amps. As we know that I1 is equal to 1 by 6 amps, so I0 is equal to 1 by 6 amps. Now from this we can calculate the value of resistance RTH. So RTH is equal to, we know V is equal to, we can write V0 by I0, and we know that RTH is equal to V0 is equal to 1 volt and I0 is equal to 1 by 6. So we can write RTH is equal to 6 ohm. So this is the value of Thevenin's equivalent resistance. Now we will start to draw the Thevenin's equivalent circuit. We know that here VTH is equal to 20 volt and RTH is equal to 6 ohm. Let us start to draw the Thevenin's equivalent circuit on the first page. So this is the Thevenin's equivalent circuit. Let us say this is the voltage source, that is VTH, and the resistor, one resistor is to be connected in series with the voltage source, and this is the terminal A and this is the terminal B. Now this is RTH. Now the value of VTH, the value of VTH is equal to 20 volt, the value of RTH is equal to 6 ohm. So this is the Thevenin's equivalent circuit of the given circuit diagram. This is how we can find out the values of VTH and RTH wherever the dependent and independent sources are present in the circuit diagram. If you like this video, kindly hit the like button below this video. If you have not subscribed my channel, kindly subscribe it. If you have any query, please write it on the comment box. I will reply. Thank you so much.